So if you stand on the shores of the Eastern Mediterranean Sea today, the water looks pretty much exactly as it did to the ancient Greeks.
Right, crystal clear.
Yeah, crystal clear, sparkling, just completely timeless. I mean, it is picture perfect for anyone visiting. But beneath the surface,
Mm.
completely hidden out of sight, there is this massive biological invasion happening.
Oh, absolutely.
And it's happening at an unprecedented scale. Like, it's fundamentally rewriting the DNA of the ocean right now. And I think the most shocking part of this whole deep dive is that we basically built the highways that used to get there.
Yeah, we really did. And, it is arguably one of the most dramatic, real-time ecological shifts happening anywhere on the planet right now.
Which is wild to think about.
It really is. We are talking about hundreds of non-indigenous species.
Hmm.
So animals and plants that had literally never lived in the Mediterranean before, suddenly calling it home.
Wow.
And they were just completely upending the local food webs.
So today, we are taking you, the listener, into the actual mechanics of this transformation, because we really want to unpack exactly how these new species are arriving.
Right, the actual pathways.
Exactly. And then we're going to examine the massive institutional awakening that's currently happening to manage them. Plus, we'll break down this concrete 5-step strategic response that authorities are using on the front lines right now.
Which is super important for people to understand.
Definitely. And the ultimate takeaway for you today is really a shift in perspective, because when you first hear about this, I mean, the natural instinct is to label these animals as, like, evil invaders.
Yeah, that's the knee-jerk reaction.
Totally. But the reality we are going to uncover in our sources today is so much more complex. And figuring out how to balance ecosystem protection with that complex reality is, well, it's the defining environmental challenge of the region.
It really is. But to understand the solution, we first have to look at the mechanics of the problem, right? Like, how do entirely new species end up in closed sea like the Mediterranean in the first place?
Right, because it's pretty closed off.
Exactly. Well, based on the research, there are 4 compounding pathways driving this huge influx. And the first, and really the most prominent one, is the Suez Canal.
Okay, the Suez Canal.
Yeah. So this is a massive man-made waterway
Right.
that connects the Red Sea to the Mediterranean. It essentially bypassed millions of years of geographic separation.
Wow, millions of years just wiped out by a canal.
Yeah, it created this direct physical corridor
Yeah.
for these marine species to just swim right through.
But, it's not just a stagnant ditch, right? I mean, it's a heavily trafficked global artery for ships.
Oh, totally.
Which ties directly into the second pathway the sources mention, which is global shipping. But let's actually get into the mechanics of that. Because how does a crab or a tiny fish from the Indian Ocean actually hitchhike on a massive cargo vessel?
Right. It's not like they're just holding on.
Yeah, they aren't just like clinging to the rudder across the ocean.
No, usually they are actually traveling inside the ship itself.
Yeah.
Specifically, they're in the ballast water.
Ballast water. Okay. Walk us through that.
So massive cargo ships, they need to take on millions of gallons of ocean water just to maintain stability and buoyancy when they aren't carrying a full load of cargo.
Oh, I see. So they just pump in whatever water is around them.
Exactly. When a ship does this in a port in, say, Southeast Asia, it sucks in local water along with all the microscopic larvae, the plankton, and just small organisms floating in it.
That is wild.
Yeah, and then weeks later, when that ship arrives in a Mediterranean port to actually take on new cargo, it discharges all that ballast water.
Along with everything living inside it.
Exactly. All those surviving organisms get pumped directly into a completely new ecosystem.
Man, so we have this physical canal acting as a corridor and then massive cargo ships acting as like intercontinental public transit.
That's a great way to put it.
And then the third pathway mentioned in the sources is aquaculture. And I imagine this isn't just about, a hole in a net where a farmed fish swims out into the wild.
No, it goes so much deeper than just obvious structural failures. I mean, yes, severe storms can damage offshore pens, and that allows farm species to escape.
Sure, that makes sense.
But it's also happening at the microscopic level. So aquaculture operations often involve importing spat.
Spat. What is that?
Oh, juvenile shellfish. They import spat or larvae from other regions. And even with really careful protocols, the water transporting them can contain hitchhiking organisms.
Oh, wow. So they bring in the water and the hitchhikers just tag along.
Exactly. Or even diseases they can just flow right into the open sea.
Okay, so those first three pathways, the canal, the shipping, and the aquaculture, they basically all deliver the species to the Mediterranean.
They do, yeah.
But delivering a species doesn't guarantee it survives once it gets there. The fourth factor seems to be the true catalyst here, right?
Yeah, absolutely.
Yeah.
The fourth pathway is the environmental enabler, which is warming waters.
Ah, okay. The local thermostat getting turned up.
Precisely. Because for decades, tropical species did occasionally find their way into the Mediterranean. But the winter water temperatures acted as this massive thermal wall.
Maybe it was just too cold for them.
Right, exactly. The new arrivals would experience mass die-offs, or their larvae simply couldn't survive long enough to establish a reproducing population.
So basically, climate change is essentially deleting the Mediterranean's natural immune system.
That is a highly accurate way to look at it, actually. As the average temperature of the Mediterranean steadily rises, that thermal wall has just vanished.
That is terrifying.
It is. Now, when a tropical species gets discharged from a ship's ballast tank, it actually finds a warm, hospitable nursery.
Because it feels like home to them now?
Exactly. The warmer water temperatures are actually triggering their natural spawning cycles. So the physical pathways provide the transport, but the warming waters provide the necessary conditions for permanent establishment.
Wow. Okay, so with the thermal wall gone and all these pathways wide open, local fisheries and marine biologists must just be completely overwhelmed by all this data.
Oh, they were. Completely overwhelmed.
Because, I mean, if you're a coastal community relying on native fish to survive, you need more than just a vague warning that the ocean is changing. You need actual help.
Right. And the sheer volume of this change is exactly what triggered a massive institutional shift. This is where the GFCM comes in.
GFCM, remind us what that stands for.
The General Fisheries Commission for the Mediterranean, they are the regional body responsible for fisheries management across the area. And they basically hit a breaking point.
I can imagine.
They realized that decades of decentralized reactive panic just weren't working anymore.
Yeah, panic is rarely a good long-term strategy.
No, it's not. What used to happen is a new toxic pufferfish would show up, a local municipality would panic, try a localized eradication, fail, and then just give up.
Wow. So it was like playing a giant game of underwater whack-a-mole.
Exactly. And whack-a-mole isn't a strategy.
It really isn't. So what did they do?
So the GFCM launched an initiative to consolidate what they call a non-indigenous species observatory.
Okay, an observatory, like a data hub.
Yes. The fundamental goal of this observatory is to bridge that fatal gap between raw science and actionable policy.
That makes a lot of sense.
Right? Because they are taking the data from marine biologists, the people who are actually tracking the biomass of these new species, and they're feeding it directly to the authorities who set fishing quotas and manage the coastal economies.
Okay, having a centralized data hub is obviously crucial. But, you know, a spreadsheet doesn't physically pull an invasive crab out of a local reef.
No, definitely doesn't.
So how does the GFCM actually weaponize this information on the front lines? Like, what does this strategy actually look like in the water?
This is where we transition from theory to the concrete 5-step Mediterranean response framework.
Okay, let's get into the steps.
Step 1 is prevention. Because once a species is fully established in the open ocean, getting rid of it is nearly impossible.
Right.
So you aggressively manage those pathways we discussed earlier.
But practically speaking, what does pathway management even entail? Because you can't just close the Suez Canal.
No, you can't close the canal. But you can implement rigorous enforcement on the shipping industry.
Like what does that look like?
That means mandating mid-ocean ballast water exchange. So ships have to flush their tanks out in the deep ocean where coastal larvae can't survive before they ever reach the Mediterranean.
Oh, that's really smart. So you just dump the coastal hitchhikers in the middle of nowhere.
Exactly. And it also means implementing stricter biosecurity protocols for aquaculture facilities, just to ensure that transport water is properly sterilized.
Okay, so it's about creating choke points.
Yes, exactly. Choke points.
But let's be realistic for a second. The ocean is vast, and microscopic larvae are exactly that. They're microscopic. So even with the best filters and protocols in the world, things are going to slip through those choke points.
They absolutely will. It's inevitable, which is what triggers step 2, early detection.
Early detection, okay.
Right. Since scientists cannot physically monitor thousands of miles of complex coastline themselves, this strategy relies entirely on building robust citizen science networks.
Wait, let me push back on this a little bit. Relying on tourists or weekend snorkelers to monitor the ocean sounds like a recipe for constant false alarm.
It sounds chaotic, I know.
Yeah, like if I see a weird fish while I'm on vacation, I have absolutely no idea if it's an invasive species or just some rare local fish I've never noticed before.
That's a very fair point.
So how does a massive scientific observatory filter out the noise of thousands of people sending in blurry underwater photos from their waterproof phones?
It's a really vital question of data integrity. But the GFCM and local researchers don't just, accept every blurry photo as fact. They use sophisticated filtering mechanisms.
Okay, how so?
Well, the reporting apps often use AI image recognition as a first pass, so it automatically flags high-probability matches.
Oh, wow, so the AI is doing the heavy lifting first.
Yes, and then regional scientific coordinators manually validate those flagged reports. But the key here really is volume.
Volume, like just having so many reports.
Exactly. A single tourist's photo might be a false alarm, sure. But if 3 commercial fishers, a dive instructor, and a tourist all upload photos of a juvenile rabbitfish in a bay where it has never been seen before.
Oh, okay. The pattern emerges.
Right, that pattern cuts right through the noise. The sheer volume of eyes in the water makes up for the lack of individual scientific training.
Okay, so the Citizen Science Network acts as the tripwire. That makes total sense.
Exactly, a tripwire.
But let's say the tripwire is crossed. A validated report actually comes in. A highly predatory, non-indigenous species has just been spotted in a small enclosed marina. What is the protocol?
That initiates step 3, rapid response.
Rapid response.
Yes, authorities have a very brief, incredibly critical window of opportunity here. The goal is localized eradication before the species has a chance to undergo a mass spawning event and spread into the wider sea.
Okay, but how do you actually isolate a marine species? I mean, it's not like a forest fire where you can just dig a trench to stop it from spreading. The water is constantly moving.
It is difficult, but you use highly intensive, localized methods.
Like what?
Well, if the incursion is in a confined area, like a port or a specific bay, authorities might actually deploy physical curtain nets to temporarily close off the entire area.
Wow, just wall off the water.
Yeah. And then they use targeted trapping, intensive culling by professional dive teams, and they even monitor environmental DNA or eDNA in the water column.
eDNA, like they are testing the water itself for genetic material.
Exactly, to confirm whether the genetic footprint of that specific species is actually gone. It is an incredibly resource-intensive sprint.
I can imagine. But, marine biology is messy, so what happens when the sprint fails?
And it does fail.
Right, like the nets don't catch everything, a spawning event happens anyway, and suddenly the species is completely outside that small bay and just spreading down the coast.
This is honestly the most difficult pivot in the entire framework. And it brings us to step 4, targeted control.
Target control. Okay.
Yeah. There comes a point where the scientific community just has to look at the data and admit that complete eradication is mathematically impossible.
That's got to be a tough pill to swallow.
It is. The species is integrated into the ecosystem, and when eradication is officially off the table, the strategy shifts away from offense and entirely into damage control.
Got it. So it's less like fighting off an acute infection and more like managing a chronic medical condition.
That is a perfect analogy.
You can't cure the disease entirely, but you can aggressively manage the symptoms around the patient's most vital organs just to keep the system alive.
That is the exact underlying logic of step 4. You stop wasting your resources trying to hunt down every last invasive fish out in the open sea, and instead you redirect all your funding and manpower to protect the vital organs of the Mediterranean.
Okay, so what are those vital organs?
The source material outlines these priority areas really clearly. We're talking about marine protected areas, coastal nursery grounds where the native fish breed,
Okay.
critical seagrass beds, and of course, high-value tourism beaches.
Let's dig into why those specific areas matter so much. Seagrass beds, for instance. Why concentrate so many resources there instead of just protecting the open water?
Well, because seagrass beds, specifically the Posidonia oceanica in the Mediterranean, they are the foundation of the entire regional ecosystem.
Oh, wow. The foundation.
Absolutely. They act as massive carbon sinks, they prevent coastal erosion, and they are the primary nurseries for almost all of the native commercial fish.
So if they go, everything goes.
Exactly. If a new grazing species like certain non-indigenous rabbitfish moves in and clear cuts that seagrass, the entire local food web collapses.
That's devastating.
It is. So targeted control means setting up intensive continuous trapping and culling specifically around those seagrass beds.
Just to keep them suppressed.
Right, just to keep the invasive population suppressed enough for the native habitat to survive.
But I mean, if we are permanently deploying resources to manage the symptoms around these vital areas, we are fundamentally accepting a totally new baseline.
We are.
We are admitting that these species are here to stay and the old Mediterranean is basically gone.
We are. And navigating that new baseline requires step 5, adaptation and education.
Adaptation.
Yes. The ecological changes are already swimming around in the water, which means human communities have to change how they interact with the sea.
What does that adaptation actually look like for, say, a local fishing town? A town that suddenly pulls up nets full of unfamiliar crabs instead of the native fish they've caught for generations.
It mostly looks like commercialization and market restructuring.
Market restructuring.
Yeah. A massive part of step 5 is developing fisheries adaptation plans.
Yeah.
So if a local fleet is suddenly catching tons of non-indigenous blue crabs, the authorities actually work to create a culinary market for them.
Oh, interesting.
Yeah. They teach local chefs how to prepare them. They educate consumers that this new species is safe and actually delicious to eat. And they create supply chains so fishers can make a living off this new reality.
Okay, so you essentially eat the problem.
Pretty much. You turn an ecological liability into an economic resource.
That's brilliant.
It is. But adaptation also involves public safety, because some of these new arrivals, like certain pufferfish or lionfish, they actually carry potent toxins or venomous spines.
Yikes. So you really don't want a tourist stepping on one.
Exactly. So step 5 mandates clear, honest communication from authorities to the public.
What kind of communication?
Distributing specific species ID guides to fishers so they don't accidentally handle a toxic fish barehanded. Putting up warning signs on public beaches, things like that.
This actually highlights something really critical about the communication aspect of all this. Because honest communication means not pretending everything is perfectly fine, right? But it also means not whipping the public into a frenzy.
Right. Finding that balance is key.
And there is a specific quote from the source material that really grounds this whole discussion for me. The researchers note that these animals are not evil.
Yes. That is such an important point.
Because it is incredibly easy to vilify a new species that disrupts a beach we love or a fishery we rely on. We throw around words like invader, pest, or plague.
We do.
But a blue crab didn't hatch a malicious plot to conquer the Mediterranean. A lionfish doesn't have an agenda. They are literally just doing what animals have done for hundreds of millions of years, surviving.
That's exactly it.
They are finding food, seeking a hospitable temperature, and reproducing.
They are simply reacting to biological imperatives in an environment that we altered.
Right.
However, the researchers are equally clear on the flip side of that coin. Just because the animals lack malice, it doesn't mean their impacts aren't totally devastating.
Right. They can still destroy an ecosystem.
Absolutely.
Yeah.
The true ethical mistake, according to the scientists on the ground, isn't the act of managing or even culling these species. The mistake is pretending the situation is simple.
Wow. Yeah, because if you take a hands-off approach just because you don't want to harm the new arrivals, you are making a choice that guarantees the collapse of native biodiversity.
Exactly.
You essentially guarantee the destruction of coastal livelihoods, and you end up ignoring severe public safety risks.
It requires an incredibly mature, highly scientific approach.
Yeah.
You don't fight nature with anger.
Right.
But you also don't surrender your native ecosystems to passive acceptance. You use the 5-step response.
Which means?
You enforce rigorous pathway prevention, you mobilize citizen science for early detection, you execute a rapid response when possible, and you ruthlessly prioritize your vital habitats through targeted control.
All while helping human communities adapt to the new baseline.
Precisely. It is really a masterclass in handling complex, messy realities.
It really is. Today, we pulled back the curtain on that pristine, seemingly unchanging beach. You, the listener, now know about the hidden, bustling migration happening right beneath the waves.
It's a completely invisible shift.
Exactly. You understand the mechanics of the ballast water highways, the disappearing thermal wall, the vital data filtration of the citizen science network, and of course the triage required to protect the ocean's vital organs.
It's a lot to wrap your head around, but it's so crucial.
It really is. But as we wrap up this deep dive, I want to leave you with a final lingering thought to mull over.
Okay.
We've spent a lot of time discussing how to manage these quote-unquote non-indigenous species. But think about this. If these animals are only arriving because of man-made shipping channels we literally dug through the desert, or if they are only surviving because of the artificially warmed waters of our changing climate,
Right.
are they really invaders? Or are they simply ecological refugees adapting to the new world we built for them?
Oh, wow. That's a powerful way to frame it.
At what point do we have to look in the mirror and realize we are the ultimate architects of this whole migration?
We really are.
Just something to think about the next time you look out at that crystal clear water. Thank you so much for joining us on this deep dive. Stay curious, keep asking the hard questions, and we will catch you next time.